I'm going to record here. So today we're going to be talking about introduction, or we're going to do an introduction to sampling. Okay, we already talked about the idea, and we talked about number 1 and number 2 here. So let's recall some information. You have a population, and then you would have a sample, right? So the goal of any sample is to provide insight about the larger population, okay? So the process of drawing conclusions about a population of the basis of sample data is called inference. And the sampling design describes how to choose a sample from the population. So in other words, we refer to the process of choosing the sample as sampling. And we can think of the sampling design as the instructions and the act of sampling as following the instructions. Okay? So for example, if you have your population and you have your sample, then the sampling design comes from your population, and so does your sampling. And that goes into your sample, but from your sample, you can do what? Inference. Good. You have your inference. And you can also make your conclusions. Very good. Okay, so what this would look like, I see you writing, so I'll give you a second here. So what this would look like is you would have your sampling design, and from your sampling designs, you can choose good sampling designs, and you can also have poor sampling designs. Okay, that's a possibility. So now we need to talk about simple random sampling, stratified random sampling, cluster random sampling, convenient sampling, and volunteer sampling designs. Okay, these are all possibilities, but what are they really? Okay, so the sample is not a perfect representation of the population. This leads to error and uncertainty. Okay, we want to make sure that the sample exhibits characteristics typical of those possessed by the target population. Okay, so again, with sampling designs, you can get good sampling designs and you can have poor sampling designs. Examples of good sampling signs good sampling designs. You could have simple random sampling, stratified random sampling, and cluster sampling. Cluster random sampling. I can talk, I promise you. Poor sampling designs, you can have convenience sampling design and volunteer sampling design. Okay, so we're going to talk about good sampling designs for a minute. Another example here that's not there that I'm going to add is systematic. So we'll add another box. Systematic random sampling. These are all good sampling designs. What questions do you have so far? Okay, so now what we're going to do is go over what some poor sampling designs are and examples there, and then we're going to go over the good sampling designs and go over some examples there. Okay, so let's zoom in on the poor sampling designs. Okay, so let's look at this portion here. A convenient sample, a convenient sample is a sample selected by taking the members of the population that are easiest to reach. Okay? A convenient sample is a sample that's selected by taking the members of the population that are easiest to reach. So, for example, it's fast and cheap to find people at a public place, okay, such as the mall, to survey. However, there are concerns about using mall shoppers to reach general conclusions about the broader population. First, mall shoppers tend to be more prosperous than the population as a whole. Second, mall shoppers are frequently teenagers or retired. Finally, the type of people selected may depend on the time of day that the survey is completed. All of these features contribute to the sample failing to be representative of the population. Convenient samples from a mall tend to over represent the middle class. Does that make sense to you or no? Respond. I see heads nodding yes. Are there any questions about this? What questions do you have about this? Online? Do you have any questions? If so, what are they? There's no response. Please respond. Okay. Another example, a convenient sample regarding the president's approval rating taken at a political party's national convention that's biased. Okay. So that's another example of a poor sampling design. Okay. So what's the takeaway? Poor sampling designs lead to bias. They lead to bias. Okay. A voluntary response sample consists of people who choose themselves by responding to a broad appeal. Okay? It consists of people who choose themselves by responding to a broad appeal. Okay? An example here, online surveys found on websites. How many of you have been on websites and had surveys happen? Raise your hand. Okay? This is another example. So, online surveys found on websites for which anyone can respond are an example of voluntary response sample. Okay? The small minority of people that choose to respond are generally passionate about the topic. People who take the trouble to respond to an open invitation are usually not representative of any clearly defined population. Okay? So, this is an example that you see happen daily. Okay? Let's talk about good sampling designs. So, a note here, personal choice, whether it be the respondent's choice to participate or the researcher's choice as to which individuals to include, leads to bias. We can eliminate personal choice and reduce bias by selecting the sample using random chance, specifically probability. Okay? We call this sampling, we call such sampling methods or methods like this random sampling. So random sampling, let's not cross it out, let's highlight it. Random sampling is a good sampling design. Okay? Anytime you get to see the survey results, the first question that we should ask is whether the sample was chosen randomly. Okay, so this is something that you'll need to remember. Okay, a definition. So we're covering a lot of definitions today. You want to make sure that you learn these and know when to apply them. Okay, so a simple random sample of size n consists of n individuals from the population chosen in such a way that 1, every individual has the same chance of being selected. 2, every subset of individuals has the same chance of being selected. Okay? Note, steps for taking a simple random sample, or SRS. Assign each member of the sampling frame a unique numerical label. Okay, so a sampling frame was when you have a list of individuals from which you select the sample. Okay, so assign each member of the sampling frame a unique numerical label. Then use a random number generator to select the individuals. Does that make sense? Okay, so remember what these are. Okay, and you look here. Every subset of individuals has the same chance of being selected, which is what you said, and every individual has the same chance of being selected. Here, not everyone takes English Comp 1, right? Not everyone. Random samples are typically selected using technology, okay? This is easily accomplished in R using the sample function. So the way this would be entered in R is as follows. You would have to write sample, parentheses 1, colon, 21, comma 5. So whenever you go through lab 2, Ms. Glass is going to go through and show you how to enter all of this in R. What questions do you have? Okay, so example 4. I wish to estimate the average amount of current student debt for all undergraduate students at High Point University. For convenience, a simple random sample of 100 students taking English Comp 1 is selected. Since the sample used SRS, is it likely to produce a good estimate? Take 2 minutes and discuss this with your neighbors. Online, discuss it with each other. Minutes, discuss this with your neighbors. Discuss it with your neighbors. Online, discuss it with each other. I don't hear you discussing it with each other. Unmute your mics and discuss it with each other. Make sure you're working on this, not texting. This. Okay. Make sure you're working on that. We'll give you 30 more seconds to discuss it. Okay, everybody's paused and stop because you already answered it, even online. So, since the sample used SRS, is it likely to produce a good estimate? What's your answer? No. No? Why? Because it doesn't give an equal chance for each subset of individuals. That's correct. And so say it again. No, because what? It doesn't give an equal chance for each subset of individuals. It does not give an equal chance for each subset of individuals. What do we know about SRS? What do we know about SRS? It's supposed to be a random, unbiased choice. It's supposed to be a random, unbiased choice. Very good. So then you go back English Comp 1. Very good. What is this an example of? What kind of sample is this? Say it again. A convenience sample. Very good. This is a convenience sample. Very good. What questions do you have here? Okay, let's go over a few more definitions. A stratified sample is chosen by, let's highlight this, a stratified sample is chosen by one, divide the population into subgroups or strata that have some common characteristic. Two, for each stratum, obtain a simple random sample of size that is proportional to the size of the stratum. And then three, use all individuals obtained in step two as your sample. Okay? Another definition, a cluster sample, a cluster sample is chosen by one, divide the population into subgroups or clusters that have some common characteristic. Two, obtain a simple random sample of clusters. And then three, use all members of the clusters obtained in step two as your sample. So we're going to put this all in the same view. So example 5, consider the following illustration. You have something here and you have something here. You have a population and then you have a sample chosen, which represents a stratified sample and which represents a cluster example, or not example, which represents a stratified sample and which represents a cluster sample. What's the difference? Take a couple minutes. Look at these illustrations. Figure out which one is a cluster sample, which one is a stratified sample, and point out the difference or differences. Take a couple minutes and discuss this with your neighbors. Online, discuss it with each other. Does anyone have questions while you're working? Okay, you have more time to discuss it. So figure out which one is a cluster and which one is a stratified.
Because I didn't know how to convert the data into Excel. Just got the lab badges. This needed to be downloaded. So converting that to an Excel file. Because if you put that into R,
Which one?
then
Converted to Excel.
yeah.
Did she give you steps to do that?
No, but for some reason it only happens at substance. When I opened it, it was an Excel file.
Really?
Yeah.
Where did you download it from?
Right.
Is it a pages file?
Yeah.
I still used it as a pages file and it worked for me.
It didn't work for me.
It did not.
No.
This
I
is
had to
lab
put
one.
it into Excel and then
You can just copy and paste
So
it.
if you copy all of this. So there's a question about lab one, right? Whenever some people downloaded the CSV file, it did not download into Excel, and it looked like a text document. What you can do is copy that information into Excel, and it should be separated in the columns like it would be. So you can just copy that and put it into the software. Lab one.
when does that do? Next week.
Yeah.
Next
Were we
Thursday.
supposed to start it?
Yes, you were supposed to start lab one. Did you get it?
Oh, thank you.
You're welcome. So lab one, this is a pause from example 5. It's worth answering your question since you already have questions about that. Lab 1 is due next Thursday, okay? Make sure that you go ahead and work on that and bring your questions, if you have them, to Miss Glass on Monday, or you can come to her office hours or email her. Also, you can work in groups to discuss this, right? So collaboration is a big thing in math. Go ahead.
I was going to say, will she be back from?
She'll be back on Tuesday. She'll be back on Tuesday. You can actually come to her office hours. She'll be back tomorrow.
Okay.
She'll be back on campus tomorrow.
Perfect.
What other questions do you have? Okay. So looking at these illustrations, what is this an example of? It's a cluster sample. Good. So this is a cluster. And what is this one? Stratified. What's the difference?
In the cluster sample, the subgroup, you use all the individuals. In the stratified, you take a subgroup and you take certain, well, not certain, you take random individuals from each subgroup.
So say it one more time.
In a cluster, you take it, for your subgroups, you take all the individuals. You select a couple subgroups and you take all the individuals.
So we took all the individuals?
In that group.
In the specific ones that we chose. Good. So for the cluster, for the specific samples that we chose, we took everyone from those samples. Good. And someone else, good for you. Someone else, why is this a stratified? Yes.
You're taking like smaller samples from each of those strata that are chosen, not all of them from some.
Yes. You're taking certain one, or you're taking specific ones from there instead of taking all of them. Very good. Okay. Question. If we select 2 random samples from the population, would you expect to get identical results? No, why not? You're right. Why not? Say it again. Because it's random, yes. And what do we know about the individuals in each sample? Will they give the same results or different results? Different results. Very good. So, no. Okay? Because if it's random, the individuals in each sample are different. Which will give different results. What questions do you have? Bless you. You're welcome. What questions do you have? Okay, so this is the lecture for today. What are some things to point out? We talked about sampling, we talked about poor sampling, and what other kind of sampling did we talk about? Good and poor sampling. What is an example of good? Yes?
Were you going to go through the systematic sampling?
No, we weren't going to go through that. These are the main things that she wanted you to get from this. So the question was, were we going to go through the systematic sampling? No. This is really what she wanted you to get from this section. Good question. What other questions do you have? Okay, so make sure you understand the difference between stratified and cluster samples. Make sure you understand convenient samples, voluntary samples, voluntary response samples, all of that. Okay, if you have questions about R, I'm going to refer you to Ms. Glass for that. Okay, your lab 2 you'll do next week, and lab 2 will be using R. Okay, if you want to stick around now and work on lab 1 with your classmates, you can feel free to do so. I'll stick around for a little bit and I'll be available to you if you want my help. Otherwise, this is all that's planned for today. Okay? Make sure you printed your first and last name on the attendance. Where's the attendance sheet? Everybody has to get it. Make sure you pass it around. Everyone's Make sure you print your first and last name on the attendance if you're leaving. If you choose to stay, feel free to stick around and I'm happy to help. If you choose to leave, have a good rest of your day and Miss Glass will be back next week. Thank you. Have a good one. Thank you. Have a good one. Thank you. Have a good day.